Hello friends, welcome to Factrolz Telugu. Friends, in the last class we are already completed about the temperature and the kinetic energy. And we also did the activity 3. So now let's move to the next concept, that is activity 4. Friends, here they are saying us about, so take one water container. That means take a container and fill half of it with the water, and next, so up to a particular heat, that is a 60 degrees Celsius, heat the water. After heating the water, so take a cylindrical transparent glass jar. Okay, and next fill half of it with the hot water. So again take a cylindrical transparent glass jar and fill it with the water, and next, so very gently pour coconut oil over the surface of the water. That means on the layer of water, again another layer we are adding, that is the coconut oil. So that we have to take care while pouring the coconut oil that the water and the coconut oil does not mix with each other. Okay, so next, so put a lid with the two holes on the top of the glass jar. That means take a lid or cap, so make the two holes. So the two holes must be in the size of we will keep the thermometer in the two holes. Okay, so next we have to take the two thermometers and we have to insert them into the two holes. So one is with the deeper, that means one have to be inserted inside the water, and another up to only the coconut oil. Okay, like that we have to insert, they are also shown as in the figure. So like that we have to insert the two thermometers. Okay, so next, so they are asking us to observe the readings of the two thermometers. So what happened when we kept the thermometer in any hot substance? The mercury level will be raised. It's right. The reading of the thermometers kept in the water decreases, while at the same time the reading of the thermometer kept in the oil increases. Why? Because initially the water are at the 60 degrees and the coconut oil is not containing any temperature, right? So it is having the less temperature and water having the more temperature. So that's why what will happen here, the two bodies are kept in the thermal contact. So that's why they have to attain so same degree of hotness. So that's why the heat energy will takes place from the water to the coconut oil. So that's why here the reading of the thermometers will be different, like so the whatever the thermometer kept in the water will be the level, the mercury level will be decreases, and the heating level, that means the coconut oil level will be increases. So here they are asking a question, why does this happen? So if you know the answer, keep me in the comment box why this is happening. So see the answer now. So because the average kinetic energy of the molecules of oil increases while the average kinetic energy of the molecule of water decreases. Here this is the clarity point. So why here? So because the kinetic energy, that means average kinetic energy that is present in the molecule of oil is increasing. Why? Because heat energy is transferring, and while the average kinetic energy of the molecule in the water decreases. Why? Heat losing. So in other words, the temperature of oil increases while the temperature of water decreases. So this is the answer for this, why this happen. So can you say the water loss energy? So this is another question, that so will you say me that the water loses energy or not? So from the above discussion, it is clear that water loses energy while the oil gains energy. So this is the main concept which we are discussing from the starting concept. When some body gains heat, that means the body also gaining some of the energy. When the body is losing its heat energy, that the body is also losing its energy. So because of the temperature difference between the water and oil, so the some heat energy flows from water to oil. This means the kinetic energy of the molecules of water decreases while the kinetic energy of the molecule of oil increases. Okay, so next one. So can you now differentiate between the heat and temperature based on the discussions we have made of above activities? So up to now we have discussed about the heat and the temperature. So many conditions we have seen and many things we have proved and many activities we have seen. So then now we can come to a conclusion, right? So why? Because we have seen some of the concepts regarding the heat and some of the concepts of temperature. Then we will come to a common point, like with activities 2, 3 and 4 we can differentiate heat and temperature as follows. Like heat is the energy that flows from the hotter to a colder body. So this is the pakka point. So when heat energy always flows from the hotter to the colder body. And next, temperature is a quantity that denotes which body is hotter and which is colder. So temperature, that is the one quantity which is used to measure that a body is hotter or colder. So temperature determines direction of heat, that means energy flow, whereas heat is the energy that flows. So here the common point is heat is the energy, but the temperature is direction of flowing of energy. Okay, so this is the last and final point, the conclusion of heat and temperature. Okay, so if you have any doubt, comment in the comment box, I will clarify your doubts. Okay, we will next go into the concept, that is a specific heat. So up to now we have discussed about the heat, but here they are saying specific heat. What is the specific heat? We will discuss now. So here there is another activity, that is activity 5. So here they are saying that take a large jar with water and heat it up to 80 degrees Celsius. Okay. So here we are taking one large jar and we are pouring a water and we are heating it up to the 80 degrees Celsius. Here particular temperature, that is 80 degrees Celsius. Now next we are taking two identical boiling test tubes. So that means already you know the test tubes which are present in the laboratory. So like these two are boiling test tubes with the single hole crocks. That means they have the single hole. So crock means that is the cap, like so closing the mouth of the like lids. So for, like the lids. So one of them is filled with 50 grams of water and another with the 50 grams of oil. Okay, so one test tube we are here we are taking two liquids. One is the oil and one is the water, but we are taking same amount, 50 grams 50 grams, and we are filling one test tube with the 50 grams of water, another with the 50 grams of oil, and both are at the room temperature only. So we are not heating the water or not heating the oil, so both are at the room temperature. So now insert the two thermometers through the holes of the crocks. So that means, so we are inserting, so at the beginning we taken a single hole cocks. So that's why, so in that, so we are inserting the thermometers so into the two test tubes. So now clamp them to the retort stand and place them in a jar of hot water as shown in the figure 2. So observe the figure. So like however they place it, they have taken one stand and the water in that they have placed the two test tubes which are hanging to the rods. So like this we have to place the two test tubes which is present inside the thermometer. Now we have to observe the readings of the thermometer every 3 minutes. Okay, and note the readings in your notebook. Like so here the question is, in which test tube does the temperature quickly rise? That means like in which test tube, so like fastly it will rise the temperature. So if you know the answer, comment in the comment box. So next question, are the amount of heat given to the water and oil same? Yes, they are same, right? The both of the heat given to the water and oil are same. So how can you assume that? Like how can we prove that? Like, so we believe that the same amount of heat is applied to water and oil because they are kept in a jar of hot water for the same interval of time. Yes, right here there is, see, you can see, observe, there is a jar, that is, so this is the jar. So this has the 80 degrees Celsius of the water which has a temperature, and the within the same time only we have kept these two test tubes, boiling test tubes. That's right. So then we can say that the, so amount of heat given to the same to the two water and oil, and within the same time. Okay, so we observe that the rate of rise in temperature of oil is higher than the rise of temperature in water. Okay, so why does this happen? So like think, why does this happen? So we conclude that the rate of rise in temperature depends on the nature of the substance. So the, so here we can conclude this point. Like like the the heatness of the or heating, like if you heat any something, so the heatness or like the temperature which will rise is depends upon the nature of the material. So like it will easily take the temperature or it won't take easily temperature, like that. So it will depends upon the like nature of the substance. Okay, so by this we can prove this statement. So next, activity 6. So here they are saying that the take 250 ml of water in one beaker. Okay. So one beaker we are taking 250 ml, a small beaker. This is a small beaker, and 1 liter of water in another beaker, a large beaker. That means 250 ml in the small beaker, 1 liter in the large beaker. Here beakers are different, small size, large size, and here the quantity of water also different. One is 250 ml, another one is 1 liter. Okay, and now note down their initial temperature using a thermometer. Initial temperature should be the same. Okay, So we have to make sure that the two temperatures are at the same. Okay, now heat the both beakers till the temperature of water in the two beakers rises to 60 degrees Celsius. Here, keep it in mind, we are making the two beakers with the same temperature, but we are not taking the time. So here both have to be heated up to they reach 60 degrees Celsius. Note down the heating times required to raise the temperature of water at 60 degrees Celsius in each beaker. Okay, so which beaker needs more time? So can you guess? And if you know, keep it in the comment box. So you will notice that you need more time to raise the temperature of water in large beaker when compared to the water in the small beaker. Is right. So that means you need to supply more heat energy to water in large beaker, like greater quantity of water. Why? Because in the large beaker it has 1 liter of water, and the quantity of water is more compared to the first beaker. Then water in small beaker for the same change in temperature. Okay. So for same change in temperature of amount of heat. So here heat is denoted by capital Q. Okay. So heat absorbed by a substance is directly proportional to its mass. Okay. So heat is directly proportional to its mass when the change in temperature is constant. Delta T means change in temperature. Here Q means heat and M means mass. Here they are saying that heat is directly proportional to the mass of the given substance. That means if you increase the heat, like if you increase the mass, then heat also it requires some more heat. So like that. So one thing increases, the other thing also increases. One thing decreases, the other thing also decreases. But here delta T, that means change in temperature has to be constant. That means temperature has to be constant. Okay. So next one. Now take 1 liter of water in a beaker and heat it over a constant flame. Okay. Here 1 liter of water but a constant flame. So note the temperature change. That means delta T for every 2 minutes. Okay. So here what did you notice? So like you will notice that the change in temperature rise with time is constant. Okay, that means for the same mass of water, the change in temperature is proportional to the amount of heat absorbed by it. So then it means the heat is directly proportional to delta T. That means when it is same, when the mass is constant. Okay, here mass is also, here the mass must be constant. Then heat is directly proportional to the change in temperature. Okay, in the first equation, change in temperature has to be constant, then heat is directly proportional to the mass. Okay, from equation 1 and 2 what we will be get? So Q is directly proportional to M delta T. Here Q is directly proportional to M, here Q is directly proportional to delta T, then Q is directly proportional to M delta T, right? Then so here this proportionality mark we have to remove. So while removing the proportionality mark, so we will use a constant. So that's why here we use the constant S, that is the specific heat. Okay, so where S is the constant for a given substance, this constant is called specific heat of a substance. Okay, so that is specific heat of a substance. So now, so what is the formula of the specific heat from this equation? So you can see S Q is equal to Ms delta T. When we transpose M and delta T, the formula gives S is equal to Q by M delta T. So that is the formula for the specific heat. So the specific heat of a substance is the amount of heat required to rise the temperature of unit mass of substance by 1 unit. So here we can write the definition of specific heat by its formula. See here, so here it is the Q is the heat and M delta T is what? The mass and the change in temperature. That means the specific heat of a substance is amount of heat required to rise temperature of unit mass of a substance by 1 unit. Okay. So here you can see the table, they have given some of the substances and their specific heats. So in the calorie, gram per centigrade, in joule, kg, Kelvin. So see here, so for the every substance there are different specific heats. So like lead, mercury, brass, zinc, copper, iron, glass, aluminum, kerosene oil, ice, water, seawater. So like that they have the different specific heats. Okay. So here we can now discuss about the units. Like CGS unit of specific heat is calorie by gram degree Celsius, and SI unit is joule, kg, Kelvin. Okay. And here they given the relationship between specific heat, so how to change from one to another. So like 1 calorie per gram degree Celsius is equals to 1 calorie, 1 kilocalorie per kg Kelvin is equals to 4.2 into 10 power 3 joule per kg Kelvin. Okay. So 1 kilocalorie means 4.2 into 10 power 3. Okay. So like that we can change from one substance to other, like one unit to the other unit. Okay. So next, so here we have seen that the rise in temperature depends on nature of the substance. Already we have discussed this point. Hence the specific heat of a substance depends on its nature. Okay, specific heats also depend upon its nature. If the specific heat is high, the rate of rise or fall in temperature is low for the same quantity of heat supplied. Okay, so it gives us an idea of degree of reluctance of a substance to change its temperature. Okay. So now a question to you. So why is the specific heat different for different substances? Okay, here specific heat is different, right? So here we observe here. So there are different specific heat for the different substances. So why here? So we can see that. So let us find out. So see, we know that the temperature of a body is directly proportional to the average kinetic energy of the particles of the body. As right, we discussed this point in the kinetic energy and the temperature. Okay, so the molecules of the system have different form of energies such as linear kinetic energy, rotational kinetic energy, vibrational energy, and potential energy between the molecules. Yes, right. So then the total energy of the system is called internal energy of the system. Like whatever they have energy, that is all considered as the internal energy of the system. So then when we supply heat energy to the system, the heat energy given to it will be shared by the molecules among the various forms of the energy. Yes, right. This is when we substance some of the heat, it will travel to the all the part of the substance, right, and it will share to the all the molecules, right. So then this sharing will vary from substance to substance. So all the substances won't share equally. So every substances will share differently. Like one will share fastly, one will share slowly. So like that every will different from one another. So then the rise in temperature is high for a substance if the maximum share of heat energy is utilized for increasing its linear kinetic energy. So this sharing of heat energy of the system also varies with the temperature. Okay, that is why the specific heat is different for different substances. Okay, so if we know the specific heat of a substance, we can determine how much heat is needed to rise the temperature of a certain mass of the substance through certain degree by using equation Q is equals to ms delta T. Yes, right, we know the formula. Then we can able to find out the we can able to determine like rise in heat and rise in heat, like a rise in like change in temperature and specific heat. So like that we can find out the all the values, right. Okay, so next one, last concept for this video, so that is applications of specific heat capacity. So where we will apply the specific heat capacity, we will see that. So first one, the sun delivers a large amount of energy to the earth daily. Yes, right. So then the water sources on the earth, particularly the oceans, absorb this energy for maintaining a relatively constant temperature. As said, they will take the heat energy and they will maintain some of the constant temperature. The oceans behave like a storehouse of for the earth, like they are storing heat, right. They are storing heat for the, that's why they are called storehouse for the earth. So then they can absorb the large amount of heat at the equator without applicable rise in temperature due to its high specific heat of water. So what are the highest specific heat? So when we go to the equators, there it will be absorbed more amount of heat. Why? Because there the sun rays directly fall to the earth. But whereas the poles, it is very somewhat less, because the slant rays or the, so poles are far away from the sun. Yes, right. So therefore the oceans moderate the surrounding temperature near the equator. So we have observed the ocean currents like a sea breeze, land breeze, like we have observed in the previous in our junior classes. That's right. So ocean water transports the heat away from the equator to areas closer to the north and south poles. This transported heat helps moderate the climate in part of the earth that is far from the equator. So this is one of the special mechanism of our earth, so which is shown to maintain moderate heat temperature in our earth. Okay, so next, second one, watermelon brought out from the refrigerator retains its coolness for a longer time than any other food because it contains a large percentage of water. So when we take out a watermelon from the fish, so it will contain some of the coolness up to some time. Why? Because what has the greatest specific heat? Okay, and next third one, a samosa appears to be cool outside, but it is hot when we eat it, because the curry inside the samosa contains ingredients with the highest specific heats. Okay, so these are the three examples of the applications of specific heat capacity. Okay friends, so this is the today beautiful class. I think that you understood the full concepts which I have discussed. So if you don't understand anything, comment me in the comment box, I will explain again. And if you have any doubt, I will clarify your doubts. And so if you have any doubt regarding any concept, so please comment in the comment box. So like this we can make many concepts, and so I think you can understand more by making this. So this is the 10th class useful chapter. So you can, so make I after the completion I will explain all the question answers and bits also. So by knowing the heat, so we will do many works and we will have so some of the benefits also. So we will know after so afterwards, so what are the all the things. So I think you understood the chapter up to whatever we have completed. So if you have a doubt, don't so hesitate to ask me. I am ready to clarify your doubts. So and so if you know any other concepts like something, so you are eager to know, then also comment me in the comment box. I will make sure that the concepts will be in our channel. So if you want any other topics, so please comment me in the comment box. I will make sure that I will make the videos for you. Okay, so if you like the videos, like my channel, and sorry, subscribe my channel, like my videos, so share to your friends and family members. So this will help to all the 10th class students. Okay, so we will meet in the next class. We will discuss about the method of mixtures. So that is very interesting topic. We will discuss in the next class. So until then, so take care. So be careful with corona. So stay home, stay safe. So until then, take care. Bye bye.